The next thing that we'll take a look at is a Rankine cycle with a system for improving the efficiency, and that is reheating the fluids. So this is referred to as being the reheat Rankine cycle, or Rankine cycle with reheat. So, as we had talked about in the previous section, we were saying that in order to improve the efficiency of the Rankine cycle, what you want to do is you want to increase the area between the boiler line as well as the condensing line. So it was the blue shaded area that we had in the video. And so with this, what we're doing by going through reheat is we're essentially moving the curve to the right in a way, and we're minimizing the amount of moisture that would be going into the turbine. So let's begin by looking at a schematic, and then we'll look at a process diagram for the Rankine with reheat. So what we have here is the process schematic as well as the process diagram for the Rankine cycle with reheat. And we can see in comparison to the standard Rankine, we have a few changes. One of them is we now have both a high pressure and a low pressure turbine. We didn't have that before. And the other thing that we have is after going through our high pressure turbine, we send the fluid through the reheat cycle. So in terms of the schematic, those are the changes. And then in terms of the diagram, the changes are this reheat section here, where we expand partially in our high pressure turbine, we reheat, and then go back up to a high temperature and expand again. And the advantage of doing this, had we expanded directly from 3 down, we would have ended up in the 2-phase region. We would have had a lot of water droplets in our fluid coming out of the turbine, and that would be impacting on the blades and causing a reduction in efficiency. By going through the reheat, we're able then to expand out closer towards the saturated vapor line, and consequently reducing the amount of moisture that would be in the expansion steam. So with this strategy, we actually do get an efficiency improvement. So what we can say is that 40% of the efficiency improvement comes due to the fact that we're increasing the net area, the work area, that is the difference between the heat in and the heat out. And another 60% is coming from the fact that we're not expanding into the multi-phase region and encountering moisture droplets impacting on the turbine blades. So that's where we get our efficiency improvements. The second thing is that the reheat pressure is usually about 20 to 30% times the initial pressure that we have. And finally, ultimately, we could do reheat many, many times, but the economics really prevents it. And so due to economics, typically only one reheat stage is employed. So that is the Rankine with reheat. It is a way by which we can increase the efficiency of the standard Rankine cycle, and it results in improvements in the thermal efficiency of that cycle. The next thing we're going to look at in the next segment will be what we refer to as being the regenerative Rankine cycle.